for infectious disease domain from text. From Mr. Muhammad Refi Norbasi. Time is yours. using your presentation, or should we use the presentation that you have submitted? Okay. Yeah. Miss Ramila, you can start your presentation. Yeah, we can hear. perfect, please, because of the time. Thank you, Ms. Shamila. So these are a very interesting research, very important research for health. Anyone here have any question? The attendees? Okay then, I have only one question. I'm curious, you are saying that you are using transfer learning from the pre-trained model. Did you freeze, how many percent of the layer in the pre-trained model that you freeze? Did you use it all, or how did you do it? Okay. Okay, I think we can conclude with the second presentation from Ms. Shamila. Please give the round of applause. Thank you, Ms. Shamila. Now we will come to the third paper, solving the two-dimensional conduction heat transfer problem by using artificial neural network. Yeah. The presenter is Mr. Theodore Putra Agato.
Yes, correct.
Yeah, you can start your presentation now. You have around 10 to 12 minutes, and then we will continue with the question and answer.
Also, my presentation format this. Okay. Start now.
Yeah.
Okay. Thank you for the opportunity that was given to me. And this opportunity, I want to present you our paper titled Solving the Two-Dimensional Conduction Heat Transfer Problem by using Artificial Neural Network Method. Without further ado, let's start with the introduction. Next. First, we already know the rapid development of artificial intelligence, and it was proven by the existence of the ChatGPT, which solved a lot of controversial opinion of our population. And this rapid development shown no halting for a while, and artificial neural network itself start to integrate itself to many fields of study, and one of them is simulation. Next. In simulation, artificial neural network, one of them is try to simplify the equation that to solve the problem in simulation, and one of them is reversal equation. This equation help to simulate how fluid flows. And as we can see, this equation requires someone with high academic background to solve this just kind of equation. With artificial neural network, hopefully that this kind of equation can be solved just with basic knowledge of artificial neural network. So, in our research, we are aimed to see the potential of artificial neural network as the alternative of the normal way to solve this equation or the numerical approach by comparing it, the runtime of artificial neural network and the numerical approach, and the accuracy of the artificial neural network itself with the numerical approach. Next. So, the case that we use is a heat transfer conditional. Why we use this? Because it's the simplest one, but yet still used widely in our life features. And for instance, cooling. First is conditional heat transfer equation defined as following equation, which is the derivative of u toward t is equal to alpha or coefficient of heat times the second derivative of u. Since we use two-dimensional case, then the second derivative of u is defined as the summation of the second derivative of u toward x and the second derivative of u toward y. And as you can see from this equation, we can't solve it directly. So we use numerical approach in normal case in simulation. In numerical approach, we divide this equation to two parts. First, the first part, the right part, the first derivative toward t, we call it as integration of time. While the second part, the second derivative of u, we call it as the discretization of space. How we solve it? First, the integration of time, we solve it with the implicit Euler method. Euler method define the derivative of u, which in this case u is a temper that we saw, toward t is equal to the temperature of the next time minus the current temperature which is known, and then divide it with the change of time. And then we plug in this to the equation and we got this, where the temperature in the discrete space, we use the temperature of the next time. And as we can see, that there consists of three unknown parameters. So we need to solve this equation implicitly, or in other words, we must solve it in every point altogether in a matrix. And then we simplify the equation into this equation, which is equal. And then for the discretization of space, we use finite difference method. Finite difference method define the second derivative of u toward x is equal to the difference between the middle point and the before point plus the difference between the middle point and the next point. And then we divide it with the power of the difference between two spaces. And then same, it is apply same to the second derivative of u toward x, y, where the difference is the before we use it on x-axis, but this time we are on the y-axis. After we know how we solve it, we come with this final equation. This equation calculates the next temperature or the next time over the change of time. So if we done it in numerical method, we have to calculate it over and time until we reach the target of time. And in this case, we also done the same thing with artificial neural network, where artificial neural network needs to predict the next temperature or the next time over and again. And this creates a challenge for artificial network to create error as low as possible because it will inherently to the next prediction. And actually, artificial neural network can just directly predict to the final result or predict all history of the change of temperature directly, but we decide to make artificial to predict it serially, so to create a challenge for it. Yeah, next. Okay, the artificial neural network architecture, since our problem is a simple one, heat transfer, we use a simple artificial neural network architecture too. This is a SWEN neural network. First, it consists of one input layer, which is with x and y input, and then one single hidden layer which contains of n neuron and sigmoid function activation, and one output which is O. And we can say that then the prediction, we can control that the U at the next time is equal to this neural network calculation, and you might think that the loss function will be the U prediction and minus the U xi, which is it can work, but it requires a data set. While as we can know that artificial network has problem with a high amount data set. So we've used another architecture that allow more efficient and effective result, which is next, which is PIN architecture or physics-informed neural network. As we already know, the numerical approach is an approximation function and it is differentiable. One artificial neural network itself is also an approximation function, so it's differentiable. So we modify the loss function. Instead, we try to minimize the function that we have established before by minusing the left function and the right function. And then we add the other factor, which is the boundary condition that if there exists. And also we can add another initial condition. And if you wish to dataset, if we know the function partially and the dataset function partially. But in this case, we just only use the function and the boundary condition because we want to see how well artificial neural network understanding the physics law itself. Okay, next. Okay, the case we use is from this book, and the exact solution is come from also this book too. And in this book defines a case that there is a surface of metal where the height is unknown, but we limited it to the point 0 and 2. And the width is limited to the 0 to 4. And for the temperature itself, the initial temperature is 100 units. And for the boundary, left and right, is 300 units. And we already see that artificial neural network will encounter the first problem, which is the temperature is beyond the point of 0 and 1. And it's a problem because sigmoid function is limited its prediction just to 0 and 1, and beyond of that, it lost it effectively. So we need to modify this case. Next. So we modified it simply by change the temperature of 100 to the 1/3 and the 300 to 1. Next. So then we write the program. The program was written in MATLAB version R 2021B. And the main idea of our program, first we start with initialize the parameter, the neural network, everything, including the initial condition and the boundary condition. And then we start the loop by the time loop. And in this time loop, we start with the neural network training. And the neural network training itself is contained batch, where each batch is consists first with the calculation of the prediction. And then neural network calculate the loss and then update it weight and bias based on the loss. And then we check if it is reach the batch match or not. If not, we repeat the progress again until we reach it, and then we stop, and then we move to the next in the time step movement, neural network prediction, where here, for real, neural network predict the next temperature or the next time, and then reanalyze the next prediction, the temperature from the next prediction as the current temperature, and then we check if the time is reached or not. If not, we repeat again the progress. We training again, then we predict and reanalyze and check again the time until we reach the desired time. And then if we reach the desired time, we save the result and then we end the progress. Next. And then here's the result. This is the result where the total time is 1, the alpha is 1 to 0.1, and the learning rate of IN is 0.001 with the optimized stochastic gradient descent. Why we use this learning rate is because we have tried the higher one and the result is easily unstable, and we tried the lower and the result takes significantly more time to train. So we decided we use this learning rate instead. And here's the result. Okay, no, it's not very good first. And then here's the result. We need to take note that the mark rate is the unstable result. Nevertheless, the minority answer is still in a stable form. And as we can see that, give me a second. For MSA, we compare it, the results between neural network and finite difference to the exact solution that we offer from the previous group that I've mentioned. And as we can see, the MSA of the neural network is somewhat still higher than finite difference, but nevertheless, it's quite low enough to be comparable to finite difference. And we can see that the biggest problem of neural network is the average runtime that it requires compared to finite difference. As we already know that every chance of time we need to retrain our neural network again and again, thus making it taking more time to reach the solution. Okay, next. And then here is the result. This is one of the results. This is neural network, finite difference, and this is the exact solution. And as we can see that neural network managed to copy the pattern of finite difference and exact solution, even though we can see the accuracy of neural network itself from the non-linearity of the line at this part. Okay, next. And this is the error, the error of each point of the neural network and finite difference compared to exact solution. And as we can see that the high amount of error in neural network is contribute only partial point in the prediction, while the rest is low enough and comparable to the finite difference itself. And as we can see, the boundary is imposed pretty well. And with this result, we conclude that artificial neural network is a good alternative as the good alternative of numerical approach, even though our previous result indicate the otherwise. But we quite certainty because we haven't explored much about the parameter, and furthermore, we also have done the same thing to the different cats in one dimension, and we found that artificial neural network managed to outperform finite difference in one-dimensional cats. Thanks. And in further works, we're planning on trying other Python library to extend our research, and currently we have tried DDXT, and we have also tried the same case and also different cases such as advection, division, Burger linear, and equation, and thickness on film flow equation. And we already get the result, and we currently writing a report here. Okay, next. So that's all from me. If you have any questions, I will try to discuss it more.
Thank you. Mr. Theodore Putra Alberto, is there any questions from you? Okay. So if I'm right, I don't know, maybe I'm wrong. Is the input for your data is two-dimensional data set, something like that? And then you try to solve it with ANN and then compare it with the finite method?
Yeah, so the input is the x and y coordinate.
Two-dimensional.
Right.
Oh, okay. So you might be able to apply it to different case study, not just the big problems.
That's right.
Okay, very good. Thank you. That's all. Very good. Thank you. The applause for Mr. Theodore. Now we will move on to the next presentation with the paper Homonyms and Polysemy Approaches Interpreting for Indonesian English Machine Translation from Mr. Rahmat Abdullah. Are you ready?
Yeah.
Please come forward.
My own.
Oh, yeah, sure.
Sure. Thank you.
Next sendiri. Yeah, sure.
Good afternoon, ladies and gentlemen. I would like to say thank you for attending my presentation in ICTS 20 and 23. I'm Rahmat Abdullah, 33 years old. I'm a student of Computer Science in doctoral program of Institute Technology Student of University. I will present my paper conference with the title Homonym and Polysymic Approach in Term Working for Indonesian English Machine Translation. Okay, for introduction, many Indonesian machine translation studies work on disambiguous sentence features, but not on ambiguous sentence features. This research is presented by Ratu Tomo 2020 and 19. And the second, the ambiguous sentence occur because the adjective cannot be identified or paired directly with the target noun using dependency class. And this research is presented by Rindiana 20 and 19. For the introduction, one of the backgrounds of the ambiguous sentence in Indonesia is affected by homonym and polysymic features. This factor can affect the existence of error in machine implementation using Indonesian language, especially in Indonesian English machine translation. In the problems, for example, Bapak rekreasi ke Kota Malang. This the actual meaning is pada recreation to Malang City. With the previous study still extract Malang with the meaning pure, poor as an adjective and have not been able to extract Malang as a noun with the meaning Malang City because of inaccurate post-taking result. This problem is due to an error in capturing the context of the word in sentence, converting post-taking errors. Another example, bis itu jatuh terpeleset ke jurang. The actual meaning in English is the bus slipped into a ravine. Where the previous study still extract jatuh terpeleset as the verb jatuh with the meaning fell and terpeleset with the meaning slip. In fact, jatuh terpeleset is a verb phrase and has not been discussed. Therefore, the developer machine translation is needed to capture homonym and polysymic features, which can be a word or phrase. The related word in this research consists of taking word features of homonym and polysymy, word feature extraction of homonym and polysymy, and last is neural machine translation. The comparison of machine translation tasks is shown in this research. In the ICTS research can translate the sentence in basic, prefix, in lexical feature, basic, prefix, and suffix. While in the phrase feature, the ICTS only can show the neutral sentence, but cannot show the translation in homonym and polysymy sentence. Yes. And Yamin can translate the sentence in lexicals, the same with the ICTS, but cannot translate the homonym and polysymy sentence feature. In our research, we use the data set consists 1000 data train and 200 data test with a total 1200 sentences in Indonesian and English language. Here the data set representation. Double trace with the data set representation. There are 12 sentences for represent the sentence type simple, compound, complex, and compound complex. And 3 word types, neutral, homonym, and polysemy. Figure 1 shows the flowchart of the proposed feature extraction. We use the label tag result of propen and pron as known. Then we extract the terms with unigram and bigram features from each sentence using wording file. The unigram feature represents the form of a word, and the bigram feature represents the form of a sentence in the form of a phrase. In addition, we expand the terms with unigram and bigram features using synonym-based expansion to identify the word types of terms. We develop rules based on 2 conditions for generating and updating terms and label text of terms. The rules based on 2 conditions. The first, if the synonyms of the terms of the term bigram are exist, and the second, if the synonyms of the term unigram exist and the label text is different from the label text of the existing terms. We extract human feature based on a term in which the number of label text types is higher than one consisting of noun, verb, and adjective. Then we take the polysemy verb feature based on a term with one label text extracted as a bigram, where the number of the term of text type is higher than 1. Finally, the word feature of homonym and polysemy are taken based on the number of existing label text and the number of the term context type. Okay, for instance, in the result, we carry out synonym-based expansion to get synonym and other types of word-based expansion to get synonym and other types of words from the extracted terms and substitute existing terms in unigram using bigram. The synonym-based expansion result are shown in table 5, where existing terms marked in bold can be expanded based on synonyms word to find out the existing types of the terms. Then the result of bigram expansion can be seen in the synonym result of the bigram column. Here, in the sentence 2, Bapak rekreasi ke Kota Malang. Kota Malang is extracted as the bigram synonym result. And the sentence 3, di situ jatuh terpeleset di jurang, jatuh terpeleset can extracted as the bigram synonym result. In the proposed machine translation result, the sentence true properly, the proposed method can translate sentence true properly because can know the meaning of Malang as the Kota Malang. But in the previous research by reference 3 by Yamin and by reference 12 by Hoste, still cannot translate properly the sentence 2 and sentence 3, which does not distinguish the context of the term Malang in sentence 2 and cannot capture the context of the term Malang as an adjective. In the sentence 3, NMT by M. Yamin and B. Hoste has not been able to translate properly because there is an error in translating the phrases jatuh terpleset which marked in red. Neural machine translation has not grasped the meaning of jatuh in sentence 3, which expresses jatuh terpleset. Neural machine translation can still capture the context of the meaning of jatuh terpleset as 2 different words by adding the conjunction "and" in the translation result, fell, and sleep. The proposed machine translation method can successfully translate Indonesian English sentence containing semantic features lexical, concise basic, prefix and suffix, and phrases feature, concise neutral, homonym, and polysemy. The proposed words context of Malang The proposed machine translation method can properly distinguish the meaning of the word context of Malang and Jatuh. The proposed machine translation method properly translates homonym and polysemy in Indonesian sentence into English. In the evaluation result, the evaluation of the proposed machine translation using word feature extraction determines the best performance of the term list against homonym and polysemy feature. The evaluation result of the proposed machine translation for precision, recall, information, and accuracy respectively are 0.7791, 0.8428, 0.8097, and 0.7975. We also compare the information test with other studies as shown in table 6. Okay, the last is the conclusion. We propose homonym and polysemy approach interpreting for Indonesian English machine translation. The proposed word feature extraction using word to fact, synonym based expansion, and semantic similarity can extract words and phrases to identify the different types of word in the sentence, in each sentence. Then semantic similarity can properly measure the similarity value between existing words and phrases with the synonym to terms based on the highest similarity value. We also group words like homonyms in dictionary 1 and polysemy in dictionary 2. Finally, we perform the proposed machine translation using neural machine translation with the proposed word feature extraction. In future work, this proposed method is to be developed to solve more complex homonym and polysemy problems in various other types of sentence to increase the evaluation value of the proposed method. We also hope that the results of this research can be used to support text extraction in other fields, such as sentiment analysis, hate speech detection, and the others. Okay, here the last of our presentation. Thank you very much.
Okay, thank you, Mr. Ramasakula, for the presentation. Do you have any question? Anyone here as the attendees? No? So then I will ask again. It's my job as the moderator. If no one is asking, then I will ask. Okay, I'm curious on how did you detect the homonym and polysemy in a sentence?
We detect the homonym letters, the homonym terms by identifying a word which has the meaning more than two.
More than two.
More than two for homonym, and for polysemy terms, we detect by identify the word, the phrase which has synonym expansion that can has multiple meanings by word and by phrases.
Do you have any type of, did you use any type of tools to detect it, maybe a word equity or something to detect the meaning of the words?
By word, we detect the meaning of these words using word to fact, and by machine, and we adding some algorithm of machine learning.
Or you use a machine? What type of machine? What type of machine learning algorithm?
By Python.
So it is just using the word and the word to fact to detect the meaning.
Word to fact and machine learning algorithm. We combine word to fact and our own machine learning algorithm.
Okay, thank you. Then Mr. Ahmad Abdullah for the presentation today. This is anyone to answer. Oh yeah, there are one more question. There's one more question.
Yeah. What's your contribution in this research? You say what to fact and what do you take evaluation metric for the system?
Okay. Our contribution for what to fact in this research, what to fact is combined using machine learning that we will by our
But
own.
I think what to fact in machine learning.
Word to fact is, as far as I know, word to fact is
But
word embedding, a factor of word. Factor of word.
That is the part of machine learning too, I think. No.
no, we combine.
Yeah, machine learning is something
Because
like
in perfect consists of the neural network.
Yeah.
Like you use Instagram too.
Yeah, we use Instagram, but I mean, word to fact can knowing the target translation when we are combine using machine learning, because there are some target in part of speech like front, proper. So we
What's the method machine learning use in this?
to extract the target translation by detecting the part of speech level type.
so it is using post taking.
Yeah. Post taking. So the word to fact function is how to detect the number of name entity recognition in the synonym expansion result. Here the contribution
I want to know the effects of what to fact in your problem. I want to know how many effect
okay.
what to fact in your system.
Okay. In the table 5, we show the results word extraction that we use word to fact, which combining using machine translation machine learning algorithm. When we only use word to fact, we cannot extract the Kota Malang as the phrases. Word to fact only extract by unigram or only bigram. But when we extract the bigram then convert into unigram, that is, I mean, we must combine using machine learning algorithm. So we can extract the Malang as the homonym and Kota as the polyphonic tones.
Okay, is that alright? Good? Okay. Thank you, Mr. Rahmat Abdullah, for the presentation. It is very interesting because it is Bahasa Indonesia and most of us is understand Bahasa Indonesia. That's why the discussion is longer than usual, because this is human language, not machine language. That's all. I think it's enough. Thank you. Applause for the presentation. Okay. Yeah. Okay, well, we need a few minutes to.
Baca ini saya bantu bacanya gimana? Oh.
Okay, we need a few minutes.
If I'm not mistaken, Made asks about the data set. Yeah, maybe the question is about the data set, and then the first question is about the algorithm, yeah, the machine learning methodology. But the detail I cannot hear so clearly, yeah, because of the internet connection. Yeah, is Made right? The meeting chat? No, no. Or maybe we can yeah.
I will answer.
Yeah, the internet connection. Yeah, the internet connection issue. Yeah. Okay. Maybe is there any response from Mr. Lindu Manik about the question? Maybe you hear some. Okay, the internet connection is not stable. Is unstable. This is our internet connection or okay. Maybe from Lindu, Mr. Lindu, yeah. Maybe Mr. Lindu can turn off the camera. So, or yeah. What about the time? Okay, that's the question from
So I
Iman
can hear the
Satria.
questions before. Yeah.
Maybe Mr. Lindu Manik, can you answer this question? The first question in the meeting chat
Yes.
about the reason to choose those model, and then the second question is about the most important feature. Okay, Mr. Lindu Manik. Yeah, Mr. Lindu.
Yes, the questions of algorithms. Yes, the are arbitrary. So that's why I chose parts. Study would like to uh, 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 study the feature selection, not the algorithm itself. So the reasons. And the second questions, what was this is the we do not answer as I mentioned before the research, so the feature research. The most important features, but unfortunately, in the study we do not perform. That's all the answer.
Yeah, that's all the answer. I cannot hear the answer clearly. What about Mr. Made? Is the explanation can answer your question? Can the explanation answer your question? Okay, thank you. Okay,
Yes, thank you, Mr. Lindung Manik, for that.
Okay, thank you very much. Give applause to Mr. Okay. Now we are going to continue our fifth presenter, Bangun Rizky Awang Ditama, with the research entitled Quality Conformity Analysis Functional and Usability in Academic Information System using ISO ICE 25010. Okay. Have Mr. Bangun Rizky Awang Ditama join this Zoom meeting?
Yes,
Oh, okay. So, are
Laila
you
Mardatila.
Miss Laila Mardatila?
Yes, yes.
Okay, okay, okay. You can try to share your screen. Yeah, maybe open your microphone and prepare your presentation. You have 15 minutes for the presentation and question answer session. Okay, the time is yours.
Thank you. Good afternoon. Hello, everyone. I would like to introduce myself. My name is Laila Mardatila. As one of the author from this paper, our team has 3 members from Informatics Department, Institute Technology, 10 November. Our paper title is Quality Conformity Analysis Functional and Usability in Academic Information System using ISO 25010. Currently, online education more has been implemented since COVID-19. Therefore, the quality of academic information system must be considered. To measure the quality, we use framework ISO 25010. Actually, in 25,000 ISO 25010 has some aspect, but in this research, we just focus into aspect. There are functionality and usability aspect. Okay. The serious problem can arise when functional and quality aspects are not considered. This happen make user difficult in access information and complete assignment, which is can disrupt the overall teaching and learning process. The goal of the research is, of course, we can measure suitability of software quality, especially in focus functionality and usability using ISO IEC 25010. And the final, we can expect the recommendation to improve the software quality. Okay. We found some literature, and in this presentation, one of literature that we found. The first literature, functional suitability measure based on ISO 25010 for e-commerce website, showed that framework ISO 25010 is suitable to measure for website application, and it is support in the other paper, like functional suitability measurement using goal-oriented approach based on ISO 25010 for academic information system. So this paper support the ISO 25010 support to measure the quality for academic information system. And then in the other literature, we found that with the survey, before we spread the survey to the respondent, we must measure the reliability. And to measure the reliability, or we can using the Cronbach alpha, and the score of Cronbach alpha must threshold of 0.7 or higher. Okay. This is a research methodology. In this presentation, we have some steps of research methodology. Number one is study literature. So we can collect the literature to support our research and data. The second we define a set of attributes related to functional and usability based on ISO 25010. It means that from all of the menu from academic information system, we choose that is suitable with functional and usability. Then a mapping characteristic from academic information system, and then making questionnaire, implementing measurement in dataset, and analysis and conclusion. From ISO 25010, actually have some aspect, but we just focus into aspect. There are functional suitability and usability. In functional suitability, we choose to sub aspect. There are functional completeness and functional appropriateness. In usability, we choose learnability and learnability and operability. Incompleteness sub-aspect evaluate how complete the function supposed by software. The appropriateness sub-aspect evaluate how well software function completes the assigned tasks and goal. And learnability is a self-explanatory or user interface, like that. Operability is operational and consistent from the application. From all the menu of academic information system, we choose 5 menu. That menu is often used by the student. That menu is course registration, student grade, student activity transcript, student payment information, and service desk. So we focus menu often used by the student. For the information, before we spread the survey, we measure the reliability score. The score of reliability with Cronbach alpha score is 0.93. This is the result of our survey. In this table, we can take a look total, true and false, and the 5 menus. In total is a number of function or question required to achieve specific objective. In true is a number of function missing or incorrect among user objective. It's like when we are in our survey has 5.1 until 5, and the false score is 1 and 2. It means that very disagree and disagree. And true is mean that number of function or question are presented in a way that user could understand. It's mean in survey is point 4 and 5 agree and really agree like that. So we can using the formula 1 minus false divided by total, and we found the score is 0.79 for course registration, and we can use that formula to all that menu. Okay. This is for appropriateness function, the same formula. In this usability learnability, we use the other formula, but it is equal like before, but we use true divided by total, but it is equal like before formula. Okay. From the research, we have the conclusion that the student grade menu in the academic information system has the highest value among the other menu from all that aspect. And then we need to improve menu in student activity transcript because it has the lower measurement value compared the others menu. And then the suitable function and usability aspect in the student show the strong correlation with person correlation. Okay. I think that's all from my team, our team. Any question?
Is there any question for the presentation? Okay, is there any question? One. Okay, maybe I would like to ask you a question, Ms. Laila. Yeah, in this research, you conduct quality conformity analysis, functional and usability in academic information system. Yeah. What academic information system? Do you have any collaboration with any institution or like ICTS maybe campus, yeah, university, or academic information system? Is there any description detail in the information about the academic information system that you use in this research?
Oh yes, sorry. Academic information system in this research is in Telkom University. In Telkom University Surabaya.
Oh, Telkom University Surabaya.
Yeah. Yes.
Okay. Maybe my second question, is there any reason, maybe the background, why do you conduct this quality conformity in Telkom University Academic Information System?
The reason is this is the important reason. It's easy to get the survey in the academic information system, and second answer is because online education more hype now than before. So this two reason why I choose the academic information system in Telkom University Surabaya.
Okay, are you lecturer in Telkom University Surabaya?
No, but my partner, Mr. Bangun, is a staff in Telkom University. So it's easy to get the respondent.
Okay. Thank you very much, Miss Laila, for the presentation. Give applause to Miss Laila. Okay, the last but not least, our sixth presentation, Sasa Kober with the research entitled Data Trust in Logistic Price Prediction for Collaboration. Yeah. Okay, you can. Are you going to use? Okay, the mouse. Okay. Yeah, you have 15 minutes for the presentation, question and answer session. Okay. Maybe.
It's good, just forward. It's okay.
Right click.
Yeah, no. So you can also say.
Yeah. Okay.
Hello everyone. My name is Sasha Kova. I'm coming from the University of Leipzig. It's based in Germany, and I want to presentate my position paper, Data Trust in Logistics, Price Predictions and Collaboration today. And maybe you have some thoughts or discussion later for giving me new ideas. So we'll start with a short introduction. First, I introduce myself because I'm a foreigner. And then we will go into the motivation, what are the current problems in German logistics, and what's the data trust. Then, price prediction, the main topic, and at least the discussion. Yeah, I studied at the University of Leipzig, business informatics, and currently working in the logistics living lab. You can see it in the picture. It's a room for new ideas and technologies which we want to transfer into the logistics sector. Yeah, and if you in any time plan to visit Germany, you can call us and get a nice tour. Motivation. So that's Germany. We have the problem that you see that we have one of the highest parcel deliveries in Europe, and you see that many trucks are going by the same road, from not the same destination and start point, but on a part of the road they are driving side by side, and yeah, we want to reduce the truck drives because we want to reduce the emissions. And by law, the European Union decided the Green Deal, which says in the next 20 years, the emission should be zero. So to achieve that, our idea is to combine the truckloads from 3, and you can see it could be 1, and maybe it could be 1 as well, and this is already the same road could be 1. Yeah, what's the problem for sharing data in a logistics company? They don't trust each other because if they're sharing their company data, the other company can take the customers and the orders and deliveries, and then they lost the orders and have to close the company or something like that. Furthermore, a logistics company is not aware of IT stuff, like how to handle data transferring, make it securely, and have a backup and something like that. So, what's a data trust? I don't know if you heard about it. It's a relatively new topic, younger than 8 years. Data trust is a platform, a person, a company, which just have the function to share data. It's not allowed to make analytics of this data or send it to anyone or doing some other stuff. It's just the function to share the data or be an intermediate between 2 sections. So, then there are the German and European laws. There are like 30 of it, and they are connected in a way to each other, like the GDPR said, if you have the data of a person, then the data belongs to this person. He has the right to decide what to do. To achieve this, we need a data trust that the person or the data owner can say what to do with this data. The current state of the order delivery is the order comes in, and it's called the company, it's simulated by the truck. Can you deliver this parcel to the destination? It's not at any time possible to deliver it, because if the trucks are out of the road and they have no truck left, they can't deliver it. So what they do is they ask other companies and ask them, can you deliver this package to me for hopefully a lower price than mine is? And what they have to do is they have to call each other or write them and ask it for the price. Usually they pick up this 5 picked up from historical friendship, like the first 3 could be old friends, they're always calling if they have no truck left, and the other ones are some in the region. So our platform, you have to point the mouse on it, then I can click it. Yeah. Okay. So the current platform is this. So as you can see, the route is going from the capital of Germany, it's Zurich, that's Germany, to another city. And what you do now is, okay, you don't pick this one, or this one, or this one, because they're far. You pick one of the nearer locations. You can also see on the platform the delivery area of these companies, but for now, just the nearest companies. So, like, you're picking 5 of it, 3 from them, and 2 from them, or 2 of them, and then you have to ask what's the price of this delivery. So the process is, first, I calculate the price. That takes time, like 10 minutes, because they're sitting there. I was in the company and looked for how to do that. They get a call or an email, then open Google Maps, looking what's the distance, and can I combine it with another another delivery which has the same destination area. Yeah, and then looking through it and calculating the price. Then, if that's so, you have to outsource it, ask other partners, and they have to do it themselves. So then this whole process can take up to 3 hours. And as an express logistics company, time is money, and you only will have 15 minutes because there are customers which call you, and if you don't respond immediately, then they call another company. So then we looked into the parameters for our price calculation. Of course, it's the start destination point. From Indonesia to Germany, it would be higher than from Germany to Germany. And the speed, meant should the delivery be in an hour or in next week? Then of course it's a different price. And what's the delivery date? On Christmas or New Year's Eve? It's a higher price than today. And in our partners company, the weight is not really important if the weight is under 200 kilograms, because if you have to deliver a parcel immediately, then you take the next truck, which is free, put it in. The room is not full, so it could be 200 kilos more, but it's just a truck who's driving, and the costs are the same, except the fuel cost, because the package is higher rate, it takes more gas. Yeah, and then of course it needs to be cooled, or it's hazardous or liquids. Then the fuel price is also really important, and what you do is to Google the fuel price surcharge of DHL, because if one asks them, why do you calculate 17%, then they send it to the link and say, okay, if the error makes it, then we'll do it as well. Yeah, then the tools, if you cross highways, there are highway tools for trucks. And yeah, if there are, by the outsourcing, the company C takes 5% more than you, then you have to increase the price as well. And yeah, and require tools, like if it's the 200 kilo parcel, then you need a forklift. It's a lift for coming up. And they usually got just one. If the one is in a truck, in the road, because they have a heavy package, then they need to rent one. And if they rent one, then the price is also higher because they have more costs. Yeah. So they ask for the price, and they have to calculate it. So two of them don't respond. That's the matter, and the last one is too high. So I calculated 79 euro, and yeah, maybe the first or the fourth will be much harder. So, therefore, we need a price calculation. We have currently 60,000 datasets of the partners company, and the datasets which are on the platform, the Data Plus platform you saw. What we want is to use this historical data in the company's databases, which are stored in the company area, not in our platform, and the other data sets from the Data Plus make a new price prediction. So this should be the newer process. This is the old one, which takes time for calculating the price, and the newer one should be calculated by the trade model, and the agent verifies the price. If the price is wrong for some reason, then the agent have to say, okay, run wrong, make this price, or run again. So you can use it for reinforcement learning that you get better prediction. So with the price model, the goal is to get instant price of the outsourcing order, and you can decide by 1 second which you want, but we don't want to show the prices of the companies because usually they don't want it. We just want to calculate in the background and then give him 3 opinions or 3 suggestions that 1, 2, and 3 you can ask, and they will give you probably a price you can handle it or working with. You don't need to call the last one because they have too high expectations for the price. Yeah, and the platform should be integrated. Sometimes then you see, okay, the green ones, called the green ones, right? You're getting a better price than asking this one, this one. So that's the feature goal. To combine the historical data and local data bases in the companies and our data in the platform of the Data Trust, because of the rules and laws of European and Germany, we can't combine data because the ones ours, well, in our database and then in the other. So we need federated learning. So we train one model and combine them. And that should be the future infrastructure. This is new, that's the current structure on the right side. It's new, and we want to integrate the database for me. Yeah. And with the price model, if we have a price model of a single common unit, then also with federated learning, we can combine different price models of different companies in creating the overall model, combined models. What we're gonna do with that, it's not an open question, but we want to use it for some ranking, because if you are too high away, far away from the mean price, like 80 euros, and you are 150 euros, then you probably don't want to show up in the other companies' ranking. So, there are some open questions which needs to be done. It's in progress. Yeah, there are questions like which is now the method to go forward and proceeding the data for creating models. And the parameters, we only talk with 3 companies. So we find out if there are any new parameters we don't look at now. And yeah, so under the research questions, sub-research questions, 3 of them, yeah, what is the appropriate model? How can we keep the prediction model up to date? Because if you only train the historical data, and the year is skipped, and usually in the given year you're increasing your prices because the costs increased, then the model have only the old data and won't increase the price of your cost. So for that, maybe you have to add 5% or yeah, maybe retrain it with newer data which you calculate manually. But yeah, that's some open questions. And yeah, for combining the single models into a common model, there's also needs to find a way. So there are several approaches. For example, as you can think about it, price calculation can be done without AI and machine learning, because you can adjust the costs and put some percent on it to get a better price. But what we want to do is creating a model, and you can put in data from a company, and then you get a price prediction. So for calculating price, you need different calculations for each company, because each company has different costs. Yeah, and they trained, they used robust regression, XGBoost, and random forest. There's also another approach which they predict cost prediction for shipping. But for shipping, the problem is you have always the same size containers, and the ship is going at one time and not in 5 minutes. In 5 minutes, when you say please go in 5 minutes. And they use these models, so we will focus on that. And what they find out is light GDM has the best prediction power, and the MLR model has the lowest. Yeah, that's some data of this paper. And what they find also out, what is not surprising, that the distance has the highest impact. As I said, from Indonesia to Germany is going to be higher. Then it's not depending on the rate. And yeah, so the rate is also important, and it's going down to legal time. So then, thank you, and I'm open to the discussion now.
Okay, is there any question for the participants? Is there a question? No? Okay. Maybe I would like to ask you a question. Yeah. In this research, you try to develop a model to for the price prediction for the collaboration in the data trust logistics.
To increase it,
Yeah, okay. And my question is about your data set. Is there any detailed information about the data set you use here? If I'm not mistaken, you explained that you use total 600 data set. Yeah?
60,000.
Oh, 60,000, yeah, 60,000 data set. And you divide the data set into data training and data test, right? How many percent for the data training and the data set? Okay, data test.
How many persons?
Percentage.
We are currently separating data for now, because we get a database from a company which is really ridiculous, stored in 200 tables, and now we are focusing on selecting the right data for the training. So we're starting the testing now.
Okay. About the feature of the data set. Yeah, in your data set you use table, yeah, you say that many tables there. What about the column of each table? Is there any feature, feature selection that you conduct to choose the best parameter in this research, the price prediction?
Yeah, We want to start, we discussed it with the just dimensions and the weight, and going forward to the other parameters. So we're going step by step to the right.
Okay. Okay, thank you. That's all for me. Give applause to our lab. Okay, thank you very much for all the participants who attend this parallel session. Okay, maybe this is the end of our session. I apologize if there is any mistakes from me or maybe from the committee. Okay, maybe before we end this session, we will take photo together. Yeah, here or
Okay. The rules.
di sini, yeah, in this room. Okay. Maybe you can turn on the projector and share screen about the banner of ICTS, and all of the participants can go to here. Yeah, you can go to in front, go to front of the class, and we are going to take photo together before we end this parallel session. Bannernya ICTS saja. Berarti naik aja. Yang di depan ada sedikit saja dulu. Ya.
Yeah. Everyone, 3, 2, 1, go. Once again, 3, 2, 1.
Okay. Thank you for that.
I would like to inform everyone, please be at room 107 to the next event will get started.
Roll 1 second.
107.
Next one. Yeah, 1 second. Thank you.
Yeah.
Buat saya lari-lari. Ternyata udah bersemangat akhirnya jadi foto terus ya cancel. Ya udah, ayo makan. Kita aja ambil makanan lagi.